Alright, here's the start of video 6, and on this one we're going to continue on with the naming and writing formulas here. Alright, so on this one we're going to focus in on those covalent compounds. So first of all, how do we know that we're dealing with covalent compounds? Well, there's a couple different ways. When we're looking at the formulas, we're seeing two non-metals. So non-metal, covalent compounds. Now the other way would be if I'm seeing the name, then I'm seeing those prefixes like di, tri, tetra, and so forth. So those prefixes are only used in those covalent types of molecules. All right, so when we're writing the names and formulas, we got some different rules than when we were doing those ionics or those acids. But again, what I want to do when I'm doing the names anyways, so I want to break it into its parts. So I've got one sulfur here. Now, when I have one sulfur, it's the first one. I do not say mono, so I'm just going to say sulfur. And then the F4, when I have 4 of anything, then I'm going to say tetra. So this is going to be sulfur, tetra, and that ends in fluorine. I change it from that to fluoride. All right, the next one, I have sulfur, but now I have 2 of those, and I do want to say that I have 2, so I'm going to say disulfur. I don't change the name of that first element at all other than putting the prefix on it. And then I have 2 chlorine, so I want to say dichlor, and then change that ending to the IDE. All right, when we're doing the writing of the formulas from the name, it is way easier than doing ionic compounds because there's no oxidation, no crisscross. I just pay attention to those prefixes and I write down how many those prefixes represent. So when it says dinitrogen, I put nitrogen symbol, and the di means 2 of those. Followed by trioxide, so I put down oxygen for the symbol, followed by the 3. Okay, and there's the answer. All right, the next one, chlorine, no prefix there, so it's just chlorine, followed by trifluoride, which would be 3-fluorine. All right, 36. On these ones, we're doing organic compounds. Organics are those hydrocarbons, and they contain only carbon and hydrogen. So if you're seeing just those 2 elements alone then in the formulas, then we know that we're dealing with organics. If it's the name of the substance, then what we're looking for is that ANE ending. So if you see that, then you know that we're dealing with organic compounds. Okay, so when we're naming them, what we're focused in on is just the number of carbons. We don't really care of the number of hydrogens. So when I see 1 carbon, then I know that 1 carbon, we write the prefix meth to that, and then all of these hydrocarbons are going to end in ANE. Okay, and then we'll do this other one, even though it's letter D. We'll do this one next. We have 7 carbons, so I look up that, and again, this is in the gold packet, so you can see that 7 is equal to hept, H-E-P-T, and then it ends in A-N-E. All right, the next ones we've got, we know that's hydrocarbon because it ends in ene. Now we have to do it by writing the formula. So that prop tells us the number of carbons that we're dealing with. So that is carbon with 3 atoms. Now maybe the tougher part is going to be the number of hydrogens. So remember that little formula that we had learned before. You're going to take carbon times 2 plus 2. So 3 times 2 is 6, plus 2 is 8. So the number of hydrogens would be 8. And then the next one would be nonane. So non means 9, so it's carbon, 9 of them. Followed by the correct number of hydrogens, which would be times 2, 18, plus 2 more, which would be 20. All right, and the last one is that big table, number 37. I had to break it down into about 3 parts here, so let's go through that, and I think what we'll do is we'll identify as acid, covalent, ionic, or organic first, because that will kind of dictate how we write the name or how we write the formula, okay? So the first one I see magnesium, which is a metal, followed by hydroxide, polyatomic nonmetals. So that one is definitely going to be ionic. And when I name it, just break it into its parts. I have magnesium, followed by hydroxide. The only other thing I'd have to worry about is magnesium have multiple oxidation numbers, and the answer to that is no. So just as it's written, that's the answer to that one. Okay, the next one I have gold, followed by the nonmetal bromine, so that is another ionic compound. So I would say gold, followed by brom, single element, so it's ide. Now in this case, gold does have multiple oxidation numbers, so we have to decide what it is. So we look at this side of it, bromine. Bromine is a -1 charge, and we have 3 of them, so the total negatives would be a -3. We only have 1 gold atom, so that must be a +3 charge. So this would be gold, Roman numeral 3, bromide. All right, the next one definitely is an acid. It tells us it's an acid. It ends in just ic, no hydro. So that means it's something like chlorate bonded to the hydrogen. Chlorate is a ClO3, has a -1 charge, and hydrogen is a +1 charge. So it just is HClO3. The next one, ammonium carbonate. Ammonium is a positive oxidation number followed by carbonate, which is a negative. So this is basically acting like a nonmetal situation. That is an ionic compound. And the formula for ammonium is NH4 with a +1 charge. And carbonate is a CO3, and that has a -2 charge. So now I'm going to have to bring that 2 down here for ammonium. But before I do, put it in parentheses. So it's NH4 CO3, no parentheses and no number because ammonium was a 1. Okay, the next one, phosphorus nonmetal, oxygen nonmetal. So this is a covalent compound. And on those ones, we don't look up oxidation numbers. We pay attention to those prefixes. So I see 4 on the phosphorus. I'm going to say tetra phosphorus. And 10 on the oxygen, so that's going to be dec for the 10, followed by ox, and then ended in ide. And the final one on this slide is a metal potassium with a nonmetal polyatomic, so that's another ionic. Break it into its parts. I have potassium, followed by HCO3, and HCO3 is called bicarbonate. And the only other thing to worry about is the Roman numeral possibility, but potassium is always a +1. No Roman numeral needed. Continuing on, we got silver sulfate, metal, nonmetals, ionic. Write the symbols first. Silver Ag, sulfate, ends in 8. That's a polyatomic. This is SO4 with a -2, and silver is a +1. So bring down the 2, and the 1 is not necessary to write, so we're going to just leave it as is. All right, the next one is a metal, chromium with a nonmetal oxygen. So that is an ionic compound. Break it into its parts. Chromium is a Cr, oxygen is a No. And chromium, because it says Roman numeral 3, that means we're going to use the +3 oxidation number. And oxygen is a -2, so that's going to be Cr2O3. And get rid of those oxidation numbers. All right, the next one, I see that hydrogen at the beginning, so I know that that is an acid. So I pay attention to that second part, which is SO4, and that's an ending of ATE, sulfate. So you change it from sulfate to sulfuric and ending in acid. All right, the next one is a nonmetal boron with a nonmetal oxygen that is covalent. Pay attention to those prefixes when we name it. So it's going to be di-boron, and then 3 is tri, followed by oxide, because it's a single element. Okay, ammonia is a kind of a special one. That's one that actually is written in your gold packet, one that we'll come across a number of times next semester too. So that is just simply an NH3, one that you just get from the gold packet, and that is a covalent substance there. And the final one on this slide is zinc chloride, metal zinc with a nonmetal chlorine, just like so, zinc, and that also has, that does have a +2 charge to it, and chlorine is a -1, so cross them down and I get ZnCl2. And the final two on this last slide here are going to be butane, ends in ane, it's a hydrocarbon, so it's carbon, and because it's bute, that would be 4 carbons. Take that times 2 plus 2, the number of hydrogens is going to be 10. That is organic. And the last one, because it's carbon hydrogen, is organic as well. 7 carbons, so that would be hept. And then, because it's that hydrocarbon, it's going to end in ane. Alright, that is the end of video 6. Only 2 more to go. And we'll move on to number 7 now.